Hi everyone, this is a Belkin energy saving PowerPoint. It's actually a pretty unique device, and I haven't seen anything on the market like it for a long time. It's a really simple device. You hit the button here, and depending on what setting you have here, it just keeps that PowerPoint on for that amount of time. So I was using it for a fan on a fireplace. So when I'd go to bed, I'd stick it on either 3 hours or 6 hours and just give it a tap to keep the fan running. And as the fire died out, then the fan would automatically switch itself off. So simple. The nice thing is when it's plugged into the PowerPoint, it doesn't consume any energy itself until you hit that button. And even then, I think it's absolutely minimal. But unfortunately, this one died. I think it was unplugged while the fan was still running, and I think probably the fly back energy of the motor did some damage internally, so now there's absolutely no activity at all. So just thought I'd crack it open, have a bit of a look. Maybe it's something we can fix, but it might be the end of it. We'll have a look. So it does have the funky security screws, triangular ones, so that might make for a bit of a challenge. I do have these bits here for a tri-head Phillips type screw. Well, that seems to bite, so we'll give that a go. So there we go. It's not much to it. Pretty simple. Check out that fuse there. It's just a piece of wire. It must be some sort of fusing wire, but I haven't seen that done before. It's a bridge rectifier, some capacitance. So I'm guessing that might be the flyback protection on the coil of the relay. That's perhaps not sure, must be some sort of analog circuit here, or a timer, which connects to the switch for the timing. I don't see any big capacitors there though, so that's kind of interesting. So it looks like when you push the button here, the AC is going through the switch, through the black wire, down the red, through these resistors, and then across to the bridge rectifier. So it seems to kick off the DC side of things, and hanging off the DC side of it is the relay coil. So by pushing the button, you're activating the relay and starting turning the whole system on. But what's happening is when you push the button, there's absolutely no activity. Normally you see this little LED come on, which is also hanging off the DC part of it. So I might just have a quick look at the output of those caps. Okay, so there's a short. So that's across the electrolytic capacitor. This one here. Yeah, pretty much a dead short, so there's somewhere on the board a short, which are usually a little bit tricky to find. If I have a look at the relay down in this region, I can't help feeling it's related to the flyback Zener. And of course there's a short circuit on those nets, so we can't really measure it. I'm going to see a short circuit there as well. I can always put some DC voltage on here and see if any components get hot. Maybe that's one way to find the short. Let's give that a go. So I've just added a couple of jumpers here on the diodes. They're a really nice easy point to clip onto. It's essentially giving me a connection across the electrolytic on the DC path, so I'll power that up, slowly bring up the current, and poke around and see if there's something getting hot. So I've got the power supply hooked up now, and I've cranked up the current to about an amp. I thought it'd be getting warm down here in the relay, but it's actually up in this region. And if I crank up the current some more and measure with my thermometer, it seems to be the Zener, or Z1, or perhaps the cap next to it, but no, it's definitely that Zener that's getting hot. Yeah, I'm not sure what voltage this Zener actually is, but I'll take it off and we'll see if that takes the short away. Yeah, a little blob of glue they have under there for the because that's for the wave soldering process. Really makes that Zener stick to the board. Yeah, so the short's gone, so it's definitely the Zener, which is interesting. So I guess in theory we should be able to power it up, just from DC at least anyway. Oh, that's promising at least. There's an indicator light on. But I guess without the AC we're not going to see much else. But I reckon if we just find a substitute Zener, these caps are rated 16 volt. So I'm guessing maybe a 12 volt Zener or something like that. It's probably safe. I guess the relay is probably maybe a 5 volt or a 12 volt relay. I might look that up. And yeah, we'll stick a Zener on the bottom. So thinking a bit more about it, I have a feeling that Zener diode might actually be a very crude sort of regulator. But I've got one here that's actually a 9 volt, so we'll drop that in. See how that goes. There's a leaded part, so that's had to go in slightly differently. But that'll do the trick. So, moment of truth. Awesome.